We're standing in front of the Expeditionary Manufacturing Unit, or otherwise known as the EMU, and I'm talking to Speed 3D's CTO and co-founder, Steve Camilleri. Welcome.
Thank you very much.
Can you give us a bit of an overview of what the EMU is?
So this EMU is a 20-foot shipping container manufacturing solution. It's deployable into the field, and it allows you to make metal parts right at the point of need very rapidly.
Can you run us through a bit about the X-Speed we're standing in front of and the other component, the speed cell?
We're standing in front of our X-Speed printer right now. So this is a metal 3D printer. It's fully encased in a 20-foot container, so it's been ruggedized. It's designed to go into the field and operate at a range of different temperatures and environments. Behind me over here is our speed cell. So the speed cell is a machining and testing and heat treating container that contains all of the other capabilities that you need in order to make reliable, high-quality parts and know that they're right.
Excellent. And how is EMU different to Speed 3D's other equipment?
Our regular equipment is really designed for use in a workshop or a factory type of environment. So the printers themselves, they're very tough, they're very rugged as well. But those systems aren't really designed to be taken into the field and operated at high, low temperature, snow, rain, shipside, corrosion, those kinds of issues. These printers are designed for that. So we now have many years of experience on different trials around the world working with different defence forces that's fed into this design. So it's a very high maturity level product that can go right into the field.
Thank you. And your printers work with the cold spray process. Can you explain a bit how that works?
Sure, let me tell you about our cold spray process. So this system has a cold spray nozzle inside of it. So we take a metal powder, we accelerate it through essentially a rocket engine up to about 3 times the speed of sound, about 1 kilometre a second, and then that material smashes into the part and builds up, and the kinetic energy causes it to densify and bond together, and we end up with a metal part that's very high quality that we can produce very, very quickly and cheaply. So it's also very simple in terms of its mechanics and its operation, which contributes to the ruggedness of the technology.
So, Stephen, what are we printing at the booth today?
So we're printing a range of different parts that we've experienced before in the field. So let me introduce you to the idea of a mission-critical part. So this is a concept that we've discovered through all the work that we've been doing on field exercises. So a mission-critical part isn't necessarily a very interesting or complicated or sophisticated part. They can be, but most of the time they're something quite simple. And what they are is something that prevents you from doing your job out in the field. So, sometimes the really simple parts to think about, people have already thought about that. They've already brought spares with them. It's the parts that nobody's thought about, that nobody expects to break, that can kind of bring your operation to its knees out in the field. So we can very quickly and rapidly generate them with this system. So this is really designed to produce these mission-critical parts. That's what it's for.
Steve, what materials are we able to print with today, and what materials are in development?
So we have a range of materials that we're already well developed for the process. So for example, we do an aluminium alloy, 6061. That's quite a popular alloy. It's very lightweight. We do an aluminium bronze and a nickel aluminium bronze. They're very strong, corrosion-resistant materials, good applications for maritime, naval type applications. But ground forces do use them as well. 316 stainless steel is a very commonly used material. People love steel. We also print with copper, which has some defence applications, but not a lot. And of course, we're working on a range of other materials all the time. So materials like Inconel and titanium are some of the very fancy materials for making some of those parts that are really, really hard to replace. So let me tell you about what makes this EMU much better than other AM processes. So because we're using this cold spray deposition technology, that allows us to make parts very, very easily, very quickly. The process is very rugged on its own, even before we've done any work to ruggedize it. So that makes it a perfect fit for parts in the field. Is that you often need them very quickly. So being able to generate the parts quickly, and we've been tested, for example, with other defence forces and been able to design and fabricate and test parts in as little as 4 hours, which is just game-changing. Other metal 3D printing technologies, even in a laboratory context, often take days or weeks to produce those same kinds of output. Able to produce these parts very quickly, on demand, according to need, at the point of need.
Excellent. And what defence forces are we working with at the moment?
So we're currently working with the US DoD, particularly the Army, Navy and Marines. We're also working with the UK Army. We've had a lot of engagement as well with the Japanese Army. Of course, one of our highlights, I think, has been our work with the Ukrainian Army. We put a lot of effort into supporting them, and we know the process is helping them out with their needs, and we're very proud to be able to help them with that.
Fantastic. And if people would like to learn more about Speed 3D, what do you recommend?
I'd recommend our website, which we put a lot of effort into. It's got a lot of information on it. You can see case studies, you can look at the materials, the products, the technology. It's all there. And of course, you're very welcome to reach out to us. But the website's www.speed3d.com.
Thank you very much, Steve.